The steady tick-tock of a clock, the relentless march of day into night, our lives are deeply intertwined with the concept of time. We feel its passage as a constant, unwavering flow. But what if this perception is an illusion? What if time, as we know it, isn't a fundamental aspect of the universe? Recent scientific discussions have begun to challenge our understanding of this fundamental concept. The idea that time might not be fundamental, that it could be an emergent phenomenon arising from a deeper, more fundamental reality, is being seriously considered. This challenges the very foundation of our intuition about how the universe works. We are being asked to reconsider one of the most basic aspects of our existence. Exploring this radical concept requires us to delve into the strange and counterintuitive world of quantum mechanics. Quantum mechanics is a branch of physics that governs the behavior of the universe at the smallest scales. It is a realm where the familiar rules of classical physics break down, and particles can exist in multiple states at once. It is within this strange and wonderful world that we begin to see hints that time, as we understand it, might be a construct rather than a fundamental property of the universe. The journey begins by examining our current understanding of time, rooted in the classical physics of Isaac Newton and Albert Einstein. From there, we will venture into the realm of quantum mechanics, exploring how this revolutionary theory treats time and what it suggests about the true nature of this enigmatic dimension. For centuries, Isaac Newton's laws of motion and gravity reigned supreme. Newton viewed time as absolute, flowing uniformly throughout the universe. Imagine a universal clock, ticking away the seconds in perfect synchronicity for all observers, regardless of their motion. This was the Newtonian perspective time as an unwavering, independent entity. Then came Albert Einstein and his theory of relativity. Einstein shattered the Newtonian perspective, revealing that time is not absolute but relative. Time, according to Einstein, is intricately woven together with space, forming a four-dimensional fabric called spacetime. The flow of time, he demonstrated, is not constant but can be influenced by gravity and motion. Imagine two identical clocks, one stationary and the other moving at high speed. Einstein's relativity predicts that the moving clock will tick slightly slower than the stationary one. This phenomenon, known as time dilation, has been experimentally verified countless times. It highlights the flexible nature of time, subject to the conditions of the universe. Einstein's theories revolutionized our understanding of time, but they still treated it as a fundamental aspect of the universe, a continuous dimension woven into the very fabric of spacetime. Quantum mechanics, however, would soon introduce a radically different perspective, challenging the very foundation of time's fundamental nature. Quantum mechanics, developed in the early 20th century, offered a completely different framework for understanding the universe at its most fundamental level. It is a world governed by probabilities and uncertainties, where particles can exist in multiple states simultaneously, known as superposition. This is a far cry from the deterministic world of classical physics. In the quantum realm, time is treated as a background parameter, much like in classical physics. It is used to track the evolution of quantum systems but is not considered an observable quantity like position or momentum. This means that time in quantum mechanics is not subject to the same quantum fuzziness that affects other physical properties. This difference in treatment has led to much debate about the true nature of time in quantum mechanics. While the theory itself doesn't explicitly challenge the fundamental nature of time, its unique phenomena such as entanglement hint at a deeper connection between time and the quantum world. Entanglement and the dance of time. One of the most bizarre and intriguing phenomena in quantum mechanics is entanglement. Entanglement occurs when two or more particles become linked, even when separated by vast distances. These linked particles share a special connection, and the measurement of one instantaneously influences the state of the other, regardless of the distance between them. This spooky action at a distance, as Einstein famously called it, has profound implications for our understanding of time. If entangled particles can influence each other instantaneously, does this imply a deeper, non-local connection that transcends our usual notions of space and time? Some physicists believe that entanglement could hold the key to understanding the emergence of time. The Page-Wouters mechanism, for example, proposes that time could arise from the entanglement of quantum systems with their environment. In this view, time is not a fundamental property but rather an emergent phenomenon arising from the complex interplay of quantum correlations. The timeless universe, the Wheeler-DeWitt equation. The idea of an emergent time gains further traction when we consider the Wheeler-DeWitt equation. This equation, a cornerstone of quantum gravity theories, attempts to unify quantum mechanics and general relativity. The Wheeler-DeWitt equation describes the universe in its entirety as a quantum wave function, but it does something very peculiar. It completely lacks a time variable. The absence of time in the Wheeler-DeWitt equation is a profound puzzle. It suggests that at the most fundamental level, the universe might be timeless. Time, in this view, would not be a fundamental aspect of reality, but rather an emergent property arising from the dynamics of the quantum universe. The concept of a timeless universe challenges our deeply held intuitions about the nature of reality. If the universe is indeed timeless at its core, how does our experience of time emerge from this timeless substrate? This remains one of the most profound and perplexing questions facing modern physics. Emergent time, a new reality. The idea of time as an emergent phenomenon has profound implications for our understanding of the universe and our place within it. If time is not fundamental, then our perception of it as a flowing river, carrying us from the past to the future, might be nothing more than a useful illusion. The philosophical implications are profound. Our understanding of free will, for example, relies heavily on the notion of time as a linear progression. If time is an illusion, does free will still hold meaning? And what about the nature of reality itself? If the past, present, and future are all equally real in some sense, then what does it mean for us to exist in this moment? The technological implications are equally tantalizing. If we can understand how time emerges from a deeper timeless reality, could we one day manipulate it? Could we slow down, speed up, or even reverse the flow of time? While such possibilities remain firmly in the realm of science fiction, the very fact that we can ask such questions highlights the transformative potential of these ideas. Time and the future questions for tomorrow. The exploration of time's true nature has just begun. Whether time is fundamental or emergent remains an open question, a mystery that continues to fascinate and challenge physicists and philosophers alike. The answers we find will undoubtedly reshape our understanding of the universe and our place within it. As we delve deeper into the quantum realm and continue to refine our theories of quantum gravity, we can expect further insights into the nature of time. New experiments and theoretical frameworks may one day provide definitive answers, or they may lead us down even stranger and more wondrous paths of inquiry. One thing is certain, the journey to unravel the mysteries of time promises to be one of the most exciting and transformative adventures in the history of science. The exploration of time is a testament to the power of human curiosity, our relentless drive to comprehend the universe and our place within its grand, enigmatic design.